My dear friends, welcome back to Bee Spice. In this session, we'll talk about tuning parameter. Okay, so tuning parameter in the sense introduction to tuning parameters. Okay, what is tuning parameters? All those. What are all the data types, whether it's a data entry type or non-data type, all these. Then tuning parameters for a general function blocks. And typically, what are all the tuning parameters inside the PID block? Okay. Then some of the parameters are inside the switch instrument block. Okay. Switch instrument block is nothing but used to start, stop, monitor, and manipulate the status of various type of instruments. Okay. Right. Then tuning parameters of motor control block. See, basically this motor control block or the block that are applied to operate motor driven pumps and motor operated valves. Okay. So these are the things we are going to cover. Of course, this is not, a full list actually. Just I selected few important items and yeah, we can see the other items in the subsequent videos actually. Okay, friends? Right. So at the end of this video, you will get to know the insight about these tuning parameters inside these each blocks. So that is the intent of this video. Okay, one of our viewers asked for it, and that's why I'm posting it. Of course, the live, the live tuning, all these, it's a long-term plan when we buy our own system and we can simulate our own parameters and we can see the behaving, all these we can see dynamically. Okay, let's move on with the details now. Okay, intro part, friends. Okay, oh, sorry. Before going, one more point I want to update you. In fact, we have almost completed the video on how to write a control narrative. It has come out well and yeah, nicely I prepared and yeah, the example, I'll be posting it very soon, friends. Just want to update you. Thank you again for your support. Your support means a lot actually. Small support has encouraged me, to do many things for you. So that's it's like a mutual what do you call interest, right? Okay. So let's move on with the details now. The control parameter, control block status, alarm, other set points of a functional blocks. These are referred as tuning parameter. We are telling tuning. What is tuning? Yes, nothing. It's nothing. It's nothing but control parameter. Okay, control block status. Okay, alarm, other set point. These are the tuning parameters. Of course, experienced engineers knows this. They are doing in and out, but this is again targeted for freshers and intermediate. Okay, friends, right? These tuning parameters we generally called as data item. Just remember, these are data item. Okay. Some of the tuning parameters are common to most of the function block. Okay, friends. But some are specific to PID. Okay, PID you'll have a little bit different. You'll agree when you see the subsequent slides. Okay. Some additional items or parameters are present depending on the type of the function block. As I highlighted, PID looks a little bit different. That's it. So the tuning parameter of a function block are displayed in the tuning window of the function block on the HAS. This we all know, right? Yes. So this is about the a short intro. Okay, friends. Let's move on. Tuning parameters of a function block. Here also, I just want to elaborate a bit. See, the tuning parameters of a function block, two types, friends. Okay, one is the data entry type. Second is other type is a non-data entry type. So what is data entry type? The operator can change the value of some data items like alarm limits. Remember, alarm limits, set point, block mode, etc. So these are data entry type. What is non-data entry type? Data items like alarm status, PV, process variable, scale, high, low limits, SH, SL, and deviation are not changed by the operator. Okay, friends? PV means process variable, Deviation. Here you may ask, what is this deviation? See, basically, friends, deviation alarm is commonly used to report excess deviation between the desired point okay, level of a process value and actual measurement of that value. So the deviation alarm becomes active when the deviation exceeds or drops below a defined limit. So this is the deviation. Okay. Okay. Now the main point is data entry type. Okay. Alarm limit, set point, block mode, all this. Non-data entry, alarm status. Okay. There it is limit. Here status. PV scale, high, low limit, deviation. All these are not changeable by the operator. Okay. That's it. These are part of tuning parameter, but however, not tunable, cannot be changed by the operator. So that is the point. Okay, right. Tuning parameter of a, what is this? PID block, right? Yes. Okay, just a moment, friends, just a moment. Okay. As evident from the tuning panel, data items like SH, okay, scale, height, right? And SL, okay, MSH, MSL, okay. The deviation, alarm, raw value cannot be changed. Other data or other data are changeable. Okay, friends. So that is the point here. Okay, right. Then each tuning parameter has a specific range within the data has to be entered. Okay, of course. So the operator interface for the necessary tuning parameters entry can also be provided through entry from the graphic page. See, basically you have to go to the window and change all these parameters. Okay, but we have also the option to change using the graphic page. Here, friends, this being the parameters for the PID, you can see here some specific, PID, gap width, all these, what do you call the dead band, the bias, compensation gain, bias, all these are typical to PID block. This I will cover in the next, the subsequent slide in detail, but just want to touch upon here. Okay, right. So the next one is tuning parameter of the PID block. These are the, description. Mode, block mode, alarm status, process variable, raw input data, sum, totalizer value, set point value, SV, DV, control deviation, as I highlighted earlier, MV, manipulated output, okay. Then HH, high limit, low limit, okay. PH, high limit alarm, PL, low limit alarm, set point. Then VL, velocity alarm set point. Here, you may be asking, what is this velocity? See, basically here, friends, see, it's basically a parameter actually applied to control the process that the abrupt change we need to avoid actually. The abrupt change we need to avoid. So that is the velocity limit. Okay, right. Then we have deviation limit, okay, DL. Then MV high limit set point, MV low limit set point, then set point high limit, set point low limit. Of course, this PID, proportional integral derivative, we already covered also. Yeah, the G and W gap width, dead band, compensation gain, compensation bias, and preset MV. These are the typical look and feel of the parameters inside the PID block. Just get to know all these terminologies. Of course, the next level is what to tune, how to tune, all these we'll be covering in detail in the, yeah, it's a future plan. Okay, right. Now, what is this? So now we covered this PID. Now, just want to say some, example. We have covered there, we have discussed there. Some of the, data type can change and non-data type cannot change, right? Yes. Some of the tuning parameters which are normally non-data entry type, however, they can be changed conditionally. Yes. PV, a process variable of a regulatory control block, cannot be changed during normal condition. However, when the block is put in cal mode, the value can be changed. You'd have heard, right? Yeah, put it in cal mode, right? You'd have heard in the control room, right? Yes, you can do that. And also the process variable of a switch instrument blocker. See, okay, now we are talking about switch, right? Switch instrument block is nothing but used to start, stop, monitor, and manipulate the status of various type of instruments, right? Yes. So this switch instrument block cannot be changed during normal condition. However, when the block is put in sim means simulation mode, this PV value can be simulated. So these are the exceptions actually. Okay, friends? I hope this is clear. Okay, now going to the next. Here, tuning parameters of a typical function block. Okay, so I'm going to explain some of the, not explain, just want to share some outline now. See, basically, input high, low limit alarm checker. Okay, so the input high limit and low limit alarm checks. What it does, it generates an alarm to indicate the input signal is high or low alarm status. Okay, this is what are represented high, low. Okay, you can see this typical example. This is a typical example of low. Okay, when we simulate low, you can see here alarm, low alarm. Okay, here low alarm. Okay, friends, just a typical example. Okay, this is for the input high and low limit alarm checker. Right. Now, input high, low limit alarm checker. So the input high limit and low limit alarm check generates an alarm to indicate that input signal is high or low alarm status. You can see here, this is the typical example of low. Okay, can see here? Yes, that's it. Then input velocity alarm checker. The input velocity alarm check generates an alarm to indicate that the velocity is in positive direction. Okay, or velocity is in negative direction. You can see here, well, right? Yes, well plus, right? Yeah, this is the input velocity alarm checker. Then deviation alarm checker. I think we have covered, right? Yeah, deviation, right? Yes. See, the deviation, again, I want to repeat. The deviation alarm is commonly used to report an excess deviation between the desired set point level of a process value and an actual measurement of that value. Okay, right. So the deviation alarm check generates an alarm to indicate that the deviation is in positive direction. That means dV plus, or deviation in negative direction means dV minus. Okay. This is the typical example. You can see here deviation. Yes. These are all I'm just giving an example, friends, who has not, gone into the, system exposure. That is the intent actually, right? Then input open. You would have heard this IOP, right? Yeah, that is the thing. The input open alarm check generates an alarm to indicate that input signal is high limit or low limit input open. Okay, so IOP plus IOP minus. Okay, IOP plus high limit, IOP minus low limit. Okay, you can see here, see IOP minus. Okay, friends? Yes. Then output open alarm. This is OOP actually, OOP. So this is what? The output open alarm check generates an alarm to indicate that the output is open. Okay, there it's input, here it's output. Okay, friends? Got it. Then output high and low limit alarm checker. The output high limit and low limit alarm check generates an alarm to indicate that output is high limit or low limit alarming status. That is MHI, MLO. You can see here the typical example, MHI. Okay. Yes, this is how it looks. If you simulate MLO, then you will have this value. Right, friends? Right. Then, very important. Deviation count. Yeah, it's very important now. Okay, tuning parameters of a typical PID block. Okay, as I highlighted earlier, the tuning parameters present in the PID controller block covers most of the parameters available in regulatory block. Okay, right. So the parameters like PID, gap width, CB, controller bias, and compensation gain, all these are specific only to this specific controller, and these are not present in other regulatory blocks like PBI, PBI, DV, etc. So that is the point. Okay, I hope this is also clear. Tuning parameters of a PID block. Sorry, not PID block. PID block we already covered. This is the switch instrument block. Okay. So as I highlighted earlier, switch instrument are used to start, stop, monitor, manipulate the status of various type of instruments. In fact, we have an enhanced switch instrument block also, but that is used for connecting to the FF faceplate blocks. Okay, foundation field bus. Right. So this is the look and feel of the SIO block, friends. You can see here the mode, the PV, the MV, the alarm status, all these are there, right? The simulation, that bypass switch, all these are there. Can you see here? Yes. So this is the look and feel of the SIO block. Now we'll see the parameters. See, basically the parameter alarm and BSTS are not changeable. And all other parameters are changeable. You can see here, mode can be changed, alarm status can be cannot be changed. BSTS cannot be changed. Yeah, PV can. Yeah, PV answer back input value, MV manipulated value, masking time, simulation, bypass, all these can be changeable. Okay, right. So, yeah, what else? Okay, maybe, yeah, that's it, friends. Then motor control block. Okay, so, as we highlighted earlier, motor control block or the block that are applied to operate motor-driven pumps and operate motor-operated valves. Okay, these blocks may be used to start or stop motors from operation and monitoring function. Also, combining the motor control block, that is MC block, with the sequence control function, what for? To realize the automatic control on motors. Okay. These are the things, you can have a look at it, friends. You can see here the SH, scale high, scale low, alarm, all these, BSTS, right? Yes, all these are typical functionality of this MC2 block. Now you can see the parameters. See the parameter alarm, BSTS, SH, SL are not changeable, but all other parameters can be changeable. So that you can see here. So mode can be changed, alarm cannot be, block status cannot be, FV scale, cannot be. So yeah, one moment. Sorry, friends, just hold on. Yeah. Okay. Here I want to explain a bit here. Yeah, SH, FV scale limit, SL, FV scale low limit. Yes. Then we have PV answer back input value, MV manipulated output value, then SV inching output set point, PH, FV high input limit, high FV high limit set point, PL, FV low limit set point, then answer back set point. All these you can see here, right? This is the MC blocker, typical MC blocker. Actually, there are many functionalities are there, friends. Of course, I'm going to cover everything in half an hour. But for example, you can see here inching. What is this inching actually? See, inching is nothing but a function which drives or stops the motor for a specified duration according to the manual operation of the operator using the operation and monitoring function. Okay, friends? So that is the inching function, inching output. Okay. So like that, there are many actually functionalities inside. Yeah, maybe you can comment if you want. We can talk about each block in detail. So I'm going to only give the, I'm only covering only the look and feel of the block and the parameters. But I'm not covering the details here, right? Yes. So if you want, you can comment. Yeah, we can plan a session actually. Like each block, MC block, SIO block, all these block, what is inside, all explanation we can covered one by one. Okay, friends. So what else? And also here, yeah, we have bypass switch, right? Yes, this bypass switch. You may ask, what is this bypass switch? See, basically the bypass command switch, this is used to stop the answer back check function. When we give a command from the valve, the feedback comes, right? The answer back. So you want to bypass that, then you have to use this actually functionality. Okay. So that is the thing. And also what else I can show you here? So basically MC2 block is very, very, very important block actually. Yeah. So I think I covered mostly. And also, this FP means feedback, input value actually. Yeah. So that is the thing I want to tell you. And what else? So basically, you may ask, what is this FP input value actually? See, FP value is the signal that the feedback terminal, this feedback terminal, FB receives from its destination without conversion. Okay. So that is the point here. Feedback input value actually. Okay. Right. So that's all, friends. I think we have covered the PID, the functional blocks of each, parameters inside the functional block, the SIO block, and MC blocks also. So yeah, I hope it was useful. If you also feel the same, you can show your support by pressing the thumbs up button, and yeah, possible subscribe, and yeah, if possible, you can share with your friends also, friends. Okay. Yeah, next we will see you on the what do you call the control narrative part. Or if possible, there are some more controls also, like gap control. All these are already actually planned, but let's see whichever is best for the viewers. I will upload it very soon, friends. Okay. Thanks a lot for your support. Keep supporting and keep watching. This is Rambala signing off. Bye bye. Take care.